Hi guys, it's Mrs. Manley here checking in for another day of Integrated Math 1 Standard and Advanced Honors. Today we are starting out with a new word wall word. So our new word wall word is expression. And expression is any combination of values and operations that can be used to show how things belong together and compare to one another. So an expression is like an equation that's not set equal to something. For example, an expression is 3x plus 2, but an equation is 3x plus 2 equals 12. Okay? So if you printed out the copy of the word wall list that I posted at the beginning of this quarter, you can go ahead and highlight this word. If you weren't able to print it out and you are keeping a handwritten copy, then make sure you go ahead and hit pause and copy this one down. I know most of you took your EQ9 quiz last week on systems of inequalities, and I have emailed you the corrections you need to make, or those of you that didn't take it, I have emailed you a copy of the test itself so that you can go in, take it, and get that sent in to me, and that is due by Friday. But for today, we are going to be journeying into EQ10, which is systems of equations. Okay, so this is a review of something you guys did in 8th grade. So our learning target is I will be able to create and solve a linear system of equations using a variety of methods. And our success criteria, I'm going to move the screen down a little bit here, is that I know I'm successful when I can write equations to represent a linear system given a real-life situation, solve linear system of equations using substitution and elimination method, and also solve a system of linear equations by graphing, which is what we're going to focus on today. So what is a system of equations? A system of equations is when you have two or more equations using the same variables. A solution to a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. So we're going to be looking at not one linear equation, but two linear equations graphed or solved together. So in order to graph a system of equations, just like in order to graph a regular line, there are two important pieces of information that you need. Okay, you need the slope, the rise over run, and you need the y-intercept, our initial value, our starting point. So remember that we're always going to start at that y-intercept, and we're going to use the slope to rise and run. So the next thing we're going to review is the types of solutions. So again, you looked at these last year as 8th graders. And these are the different types of solutions you should have learned about last year. So again, let me just adjust my screen so you can see everything here. So the first type of solution is one solution. And this is the point where the lines intersect. So when we look at these two lines, this is the point of intersection right here. So my solution is 1, 2. We can also have no solutions, which is parallel lines. Okay, parallel lines will never intersect. So if we get parallel lines, we would write no solution. The reason we have parallel lines is because they have the same slope. They're sloping the same way, but they have different y-intercepts. So while this one starts at -1, this one starts at 2, and they will never meet. The last type is infinitely many solutions, which is coinciding lines. So if you look close, you can see there's a red line with a blue line directly on top of it. We call that coinciding. Since it is the same line, it's going to have the same slope and the same y-intercept. Therefore, it's intersecting everywhere, so it has infinitely many solutions. All right, so I am going to go ahead and apologize in advance to you guys as I forgot to bring my laptop home, and it's my laptop that I normally record on because it's touchscreen. So I'm using my regular computer at home, so I'm going to have to use the mouse to try to write. So I'm going to do my best. There won't be a lot of writing since it's graphing. So here we go. So we're just going to do a quick review here. So it says solve the following system of linear equations by graphing. So let me see if I can get a pen. Let's do purple. All right. So the very first thing we want to do is graph this first line, y equals 1/3 x. So my slope, my m, is equal to 1/3, which means I'm going to rise 1, and I'm going to run 3. And notice it's positive slope, so I'm rising and I'm running to the right. Okay, since I have no y-intercept here, that means that my slope, that my y-intercept is 0. So I'm going to start by putting a point right here at the origin at 0. And then we're going to do a rise and run. So I'm going to rise 1, run 3, put a point. Rise 1, run 3, put a point, and then I can go backwards, down 1, left 3, down 1, left 3. Now, you guys don't do what I'm doing right now. Never draw a line by hand. Make sure you use your ruler, but I don't really have a choice right now. So it's going to look pretty awful. But here is my first line. And of course, let me see if I go slower, if I could hit it a little better. Yeah, a little bit better. So there's my first line. I'm going to switch colors for my second line just to differentiate. So my second line, my y-intercept, my b in y equals mx plus b is 4. So 1, 2, 3, 4, my starting point. And then my slope is -2, which means -2 over 1. So I'm going to rise 2, because I always rise first. But since it's negative, I'm going to run to the left. And since it's a whole number, I put it over 1. So I'm going to rise 2, run 1, put a point, and then I'm out of space. So now I'm going to flip it and reverse it. Down 2, 1, down 2, 1, down 2, 1. And there I go. Again, it's not going to be pretty, but here's my not so linear line. So in this instance, if I was trying to find the point of intersection, I would have to estimate, because even without my horrible line drawing, I can see that the two lines are not going to intersect perfectly in a corner. They intersect right about here, which is at about 1.75, 0.8. So I could estimate it on that one. 1.75, comma, 0.8. Just make sure that I'm not missing any kind of line drawing ability here. Nope, pen, highlighter, eraser, that's it. All right, it is what it is. We'll keep going. All right, so for in example 2, we have y equals -2x minus 1. So my b, my starting point, my initial value, my y-intercept is -1. I'm going to start here. My slope, again, is -2, which means -2 over 1. So I'm going to rise 2, run 1 to the left. So 2, 1, 2, 1, 2, 1, and I'm out of space. And then I can go the other way. Down 2, 1, down 2, 1. And I'm ready to draw my line. Not too bad on that one. Put my arrows on there. Let's switch colors. Let's go to blue for the second one here. So on this one, my b, my y-intercept, my initial value is 5. So 1, 2, 3, 4, 5. And my slope is x. X means 1x, so 1 over 1. So I'm going to rise 1, run 1. And I'm going to go to the right because it's positive. So rise 1, run 1, there's a point. And I go backwards. And you can see where I just put the point there that I've got a red point and a blue point on top of one another, which means that's going to be where the point of intersection is. Slowly try to draw my line. There we go. So again, even though my lines are not showing it well, you can see right here that the red dot and the blue dot are right on top of one another. So when I'm looking for that solution, if I start at 0, that's at -2, 1, 2, 3. And I would write my solution as -2, 3. All right, let's move on to our next slide. All right, example 3. Y equals -3x plus 2. So for this one, my B, my y-intercept, is 2. I'm going to start at 2. And then my slope is -3, meaning -3/1. So I always rise, and it's negative, so I'm going to go to the left. So rise 3, 1, 2, 3, left 1. Down 3, right 1. Down 3, right 1. There's my line. Not pretty, but it's not bad. For my second one, let's go to green. So my B is -4. 1, 2, 3, 4. And this time my slope is the same. Okay, my slope is the same, -3/1. So hopefully you remember what we said about the different types of solutions. There is one type of solution that has the same slope but different y-intercepts, and that was no solution, which is going to make parallel lines. So we're going to slope the same way. So I'm going to go up 3, left 1, up 3, left 1, up 3, left 1. And again, even though I can't draw these lines perfectly straight for you today, you can see this is going to make parallel lines. So when we have parallel lines, you're going to write no solution. All right, last one for our foldable here. So we have example 4, y equals 1/2 x minus 1 and y equals 1/2 x minus 1. So we have the same line twice, okay? Knowing we have the same line twice, we know if we graph it twice by starting at this y-intercept of -1 and then rising 1 and running 2 to the right with my positive slope, but I'm just going to make this same line twice. So I'd be graphing the same line, one on top of the other, okay? So I'm not going to do that right now, but I am going to change color and just show you that if I start in the same place, I'm just putting it right over the top of those same points. So I'm touching at every single point. Not only am I touching every single point, but when I do connect this line, I'm touching everywhere all along the line to negative and positive infinity, meaning I'm going to have an infinite number of solutions here. So if you get one that turns out to be the same line on top of one another, bear with me while I write this out for you. So much easier with a pen. Infinite solutions. Okay. If you are able to print this foldable out and you're keeping an interactive notebook, then go ahead and fold it and put it in your interactive notebook. And we're going to take a look at a couple examples. So here's our first example. Which system of equations is best represented by the graph? Okay, so, normally on the test I'm giving you or on TN Ready, you're not going to be asked to hand graph, just because it would take such a long time to grade that hand graphing. So instead, what's going to happen is you're usually going to be given a graphed scenario, and then you're going to have to pick which system of equations goes with it. So let's talk about good testing strategies. First thing I would do is look at my y-intercepts. So I have a y-intercept at 1, 2, 3, and then 4, 5, 6, 7, 8. So I need a positive 3 and an 8. Positive 3 and an 8. 8 and not a positive 3. So I can take this one out of it. And then I've got positive 3 and a positive 8. So I'm down to 3 out of 4 choices now. Okay. The next thing I would look at is my type of lines. Okay. I can see that this line right here is rising and going to the right, meaning it's rising and running to the right, which makes it positive. And that's the line with a y-intercept of 3. So if we go through here, this has a positive slope. This one doesn't. So I can take that one out. And this has a positive slope. Now I'm down to 2 out of 4 answer choices. Okay. Again, without even finding the slope, I can look at what's left here. So I notice that I have a positive slope here and a negative slope here. And I know that my other line is rising and going to the left, which is going to make it negative. So that's going to take A out of the situation, and D will be my answer choice. Okay, so process of elimination. Use the things you know to help you answer the question. All right, next one. All right, so this one looks a little different. Select all values of x for which f of x equals g of x, because you have f of x, which is a parabola, which is quadratic, and then g of x, which is a line, which is linear. You're not going to be expected to graph a parabola. You won't do that until IM2. What you are expected to be able to do is just look at this system of equations and find those solutions, okay? So it says select all values where f of x equals g of x. Where does f of x equal g of x? Right here where they're intersecting, that means they're equal. And right here where they're intersecting, that would mean they're equal. So if I look at the point, this is at 4, 6. All right, 4, 6. And then this one is at -1, -4. Those are the solutions. This specifically says select all values of x. So my x values are 4 and -1. So I would choose B and I would choose F. Okay. Next up, what is the solution to the system of equations? If you're just asked to give the solution, just find that point of intersection. So I'm at 1, 1, 2, 3. So that's my answer, 1, 3. And that's where we're going to stop today as far as the PowerPoint goes. I am going to have you do some practice today, and you're going to do your practice on Delta Math. So, first of all, let's just talk about students who don't have a Delta Math account, okay? If you did not have a Delta Math account last year, you are going to set one up right now. If you went to Rock Springs, you should already have a Delta Math account. But if you went to Laverne Middle School or any other school, you probably don't have one. So we're going to start with those who don't have one first. So for those who don't have one, what you're going to do, let me open this up here. All right, so you're going to go to deltamath.com, and you're going to click on Create Account, which I was going to show you how to do. Yeah, so you'll click Create Account and you're going to choose student, obviously. And then it's going to ask you for the teacher access code. So the teacher access code is right here, 941085. 941085. And I'm going to have all this posted in Kidem as well. So you're going to put in your code, choose your correct class period. So make sure that you look in Kidem to see which class period you're actually in. And then you're going to enter the information that it asks you to enter, including your first and last name. If you have not set up a Delta Math account before, you're going to use your school email and your school password, with one exception. When you put in your school password, you're going to need to put an exclamation point at the end. This is because the school password is one number too short to be a password. So if everyone puts in an exclamation point as that 8th number, then if you forget your password, I can say it's your lunch number plus an exclamation point. Okay, so lunch number and exclamation point. And then you're going to click create your account and you're going to log in. Okay. For those who went to Rock Springs last year who have a Delta Math account, you're going to do things a little differently. So you're going to log in. So I created a student account so I can show you. Whoops. Now, if your username will be your school username, again, for those of you that went to Rock Springs. Your password, I'm not sure what it is. So try what you remember it being, and if you can't remember it, then you're just going to click Forgot Password and reset it. All right, so once you're in, you are going to go up here to Tools. So this again is for those who already have an account. You're going to go to Tools and Manage Login and Courses. And then you're going to click Add Teacher or Access Code. And when you do that, that's where you're going to put in this teacher access code right here, 941085. And it's going to add the class on. Okay. Once you're finished, everybody should see this screen. Okay, Delta Math upcoming assignments. And today I want you to work on the first 3 assignments. Solve linear systems graphically level 1, which is going to be like what we were just doing today. They're already in slope-intercept form. Level 2, you're going to have to change some of them to slope-intercept form. So get y by itself. And then on 3, you're going to be looking at ones that are linear and quadratic and identifying those solutions. All right. So you're only required to get 5 correct. It'll let you keep going past 5. So if you feel like you need to get additional practice, then keep going. Otherwise, once you have 5 correct, you can hit back and go to the next activity. If you're stuck in the system, you can click Show Example, and it'll go over an example with you. Okay. When you are graphing, so just to give you an idea of how to graph on here. So you're going to start, so I'll do this bottom one. You're going to start at the y-intercept of 6, and you're going to put a point there. And then my slope is -1/3. So I'm going to rise 1, go left 3, and put a point, and I'm done. Okay. Then I would do the second one, start at -2, and x, so rise 1, run 1. If you make a mistake, just click it, and it'll go away. Okay, down here, you'll put your solution in. So let me put mine back up here again. So -2, rise 1, run 1. So here's my solution, 6, 1, 2, 3, 4. I'm going to type in 6, 4, submit. It's going to ask me, am I sure? Yes. And it's going to give me a check mark to show me that I'm correct. If you're not correct, it's going to let you know you're not correct, and it's going to give you a chance to try it again. But again, this is kind of self-monitored, so you need to answer 5 correct. Once it says record 5 out of 5, or if you've done 10, 5 out of 10, once you have 5 correct, then you can go back and go to the next activity. So again, we're just working on the first 3 activities today. All right, have a great day, and I will see you again, or you'll hear me again for your next lesson.